Good morning, champions. This is going to be day 9 of your AMI packet. So I'm so glad you joined me this morning. This is what the packet looks like. Well, okay, there we go. This is what the packet looks like. It's going to be on the same day that you have this on your science, but this is day 9. Okay, let's get to it. Nope, clicking all the wrong things. There we go. All right, so let's read. Let's read letter. Let's read what it says for us for the whole day. The classroom has trapezoid tables, so these are trapezoids. There is enough space on each side of the table to seat one child. The tables in the class are arranged in a row, as shown in the picture below. So if you notice, they have put smiley faces representing each side as one child. Okay, so you're also going to be able to fit a child here, right here, right here, right here, here, and here. So, and then I'll let you count over here on this side. We can't sit anybody right here, obviously, because this is where the tables connect. So on the next, if you look at this one, we're losing actually a side on each of the trapezoids. So I've lost this side because we put them together, but I've also lost this side over here for this trapezoid. So I'm losing 2 seats, but I'm gaining 3 more. So even though I'm losing 2, I'm gaining 3 more. How many children can sit around one table? That's going to be easy to answer. All you have to do is count the smiley faces around a row of 2 tables and a row of 5 tables. Okay, well, you have 2 tables here, so you can count. Okay, what I would do for 5 tables is I would draw it out. Just draw it out and see how many. And you could even, on your paper, you could draw 2 more sets of trapezoids here. A trapezoid is just a 4-sided shape. So as long as you have a 4-sided shape, you have a top, a side, and a bottom, a top, a side, and a bottom, that's gonna help you. But remember, we're taking away 2 from the original one, but we're adding 3 additional ones. Okay, so since we're on number 1, you could sit 4. On number 2, you could sit 6. On number 3, you could sit 8. And we'll talk about 4, and then I'll let you figure out 5. The last thing it says to do is write an algebraic expression that describes the number of children that can sit around a row of tables. So just an algebraic expression that you could use to represent how many people could sit around a row of tables. And this algebraic expression will be able to give you the answer for however many tables you have next to each other, where there's 1, 2, 3, 4, 5, 6, on and on and on. And then it says explain in your own words how you found your expression. And then you have a hint here. It says you may need to draw an XY table to help you get organized and find the expression. So I have drawn an XY table here. If you notice, I put a 1 here because this is figure 1, which is trapezoid 1. Okay, so that would be tables 1. This would be the second set of tables, the third set of tables. Okay, so when you're answering row 2, this is row 2. Row 5 is not in the picture. That was the one I was saying you're going to have to add more tables and figure out how. So if you want to make a table like I did, it might be pretty helpful. So when you look at the table down here, we have figure 1, and we can sit 4 people around because we have 1, 2, 3, 4. Okay, that's where I got the 4. Figure 2, which is x2. Okay, this was 2. 1, 2, 3, 4, 5, 6. That's why there's a 6 there. And then figure 3 up here, which is the third set of trapezoid tables, we can set 1, 2, 3, 4, 5, 6, 7, 8. And so that's why there's an 8 there. Based off of how the table size is growing on table set number 4, so figure number 4, how many tables do you think will go in this one? I want you to pause the video for maybe about 10 seconds and see if you can figure out how many tables are going to go here. Just kind of analyze the information here. All right. Um, I see this side obviously growing by 1. Each time I'm adding 1. So from here to here, it's a +1. Oh, you know what? I don't need lines. I need to be able to draw. Let's do that. So when I'm growing from here to here, I'm growing by +1. When I'm going from 2 to 3, I'm growing by +1. When I'm going from 3 to 4, I'm growing by +1. Okay. What about from 4 to 6? How many am I growing by? I see that I'm growing by 2. What about 6 to 8? I also see that I'm growing by 2. So since we're growing by 2 every time on this side and we're growing by 1 every time on this side, I'm going to say that I'm pretty sure that we're going to grow 2 more going here. Okay, if I grow 2 more, I think you know what's going to go here. 10. That's what's going to go there. So I think you should be able to figure up. I think you'll be able to figure up how many people. So really, let's set this out. X equals the table number, and Y equals number of people at the table. Okay, so X is the table number, and Y equals the number of people at the table. So at table 4, 10 people can sit there. Table 3, 8 people can sit there. Table 2, 6 people can sit there. And at table 1, 4 people can sit there. You're going to have to extend your table. You're going to have to extend it down, and you're going to have to say, okay, on figure number 5, to finish answering this one, around row of 5 tables, what number is going to go here? And that's going to get you your answer for this one right here. Okay. Our last part is we need to write an algebraic expression. And if we remember, if it's an algebraic expression, that means it has to have variables. It has to have variables. I'm going to use x because x is the most common variable. Actually, we can use x and y, but since I'm just going to use x since we're writing an expression and not an equation. Okay, so here's what I know. X equals the table number. Okay. Now here's one thing I noticed. I'm trying to think about how can I get from here over here. So I could multiply 1 times 4 to get 4, and that works, but 2 times 4 is not 6, it's 8. So I don't think that's going to work. So what else could you do? Something else I'm thinking about is the numbers that I was talking to you about before. I told you that every time the table size grows, we have to take away 2, but we get 3 more. And we're also getting a +2 here. I think this +2 is going to be super, super, super helpful in your expression. I think it's going to be super helpful in your expression. But here's what I'm thinking. I usually like to start out my expressions with I like to start out my expressions with just trying some things out to see if I can come up with a solution and see if it'll work every time. And so what I'm going to do is I'm just going to start doing kind of like a little guess and check when I'm making my expression. And then if I get the answer, which is the y column, because really you should have x equals y. And you might have some other things with x, like x plus 2 equals y, x plus 8 equals y. You might have 4x plus 8 equals y, 4x plus 2 equals y. Basically what we're trying to do is we're trying to get this side of the equation to use the x's here. And when you put them in here, your answer y is going to be one of these numbers every single time. So if I use the 1 on the left side in my x, my right side has to be what's on the right side. If I use 2, my y on the right side, my answer has to come up to be 6. Okay, so like I said, I'm just going to try some things. And I tell you what, I want you to know that this x here, or this blank here that I've drawn is going to be really important. It is going to be plus something, and I'm going to let you figure out what that plus is. So I'm going to start trying some things. If I say 3x, and I'm going to say 3x plus 2. So let's go in here and use our calculator and try a couple things. 3x plus 2. 1 times 3. 1 times 3 equals plus 2. Oh, that's 5. That's too much. So that's not going to work. How about I try 4? What if we just do, oh, you know what? I have a great idea. I know that 1 times 4 is 4, so let's try that. 1x equals, or let's just do 4x equals y. Well, if I'm saying 4x equals y, I'm really saying 4 times 1 because the x on the first one is 1. Okay? What are we going to get? 4. Hey, that works on the first one. Let's try another one. So 4x, but this time we're going to use 2 as your number substituted in for your variable. So 4 times 2 equals 8. We ran into that problem I was telling you earlier. So that's where we're getting stuck. So your expression can't just be 4x. It can't just be 4x. So let's go back to the beginning. Let's try 2x. And like I told you before, your expression is going to have a plus something in it. It is going to have a plus something in it. Okay? So if I say 2x, and on the first one, remember our x is 1, so 2 times 1, I know that's 2. What could you add here to make your answer 4? Okay? On the second one right here, when your x is 2 and your y is 6, 2x plus equals 6. Okay, so we have 2 times 2, because remember, I'm not just coming up with a 2. It's figure number 2, so that's where I'm getting it from, plus equals 6. Well, I know 2 times 2 is 4, plus this number equals 6. I think you might be able to see the connection where the plus 2 is coming from now. Let me show you another one of these for figure 3 here. So we have 2x plus a number equals 8. The 8 is this right here. So I'm using the x here and the y here. So when I go down here, I just say 2 times 3, and the 3 is coming from right here, plus a number equals 8. Now, easier than this, but Mr. Smith has pretty much showed you how to get to the answer. But I want you to figure out what goes in this blank on each one of these. That is going to be your expression. And remember, you don't have to include the equal sign. So really what I'm looking for is this right here. I'm just looking for this with that number filled in, obviously, but I'm looking for this. I don't need the 2x plus whatever equals 4 or the 2x plus whatever equals 6. I don't need the equal sign because we're working with an algebraic expression, and we're going to be able to use this algebraic expression with the x in it every single time because we substitute the x for the number on this side of the column, or in this column, to plug into our expression, and that ultimately leads us to our y value. Okay? All right, I hope that has helped. I know expressions are tough. If you get frustrated with it, sit it down for a few minutes and come back to it. Watch the video again. You might even need to watch the video 2 or 3 times, but I think you're going to have no trouble at all with A. I think B might be a little bit more challenging, but I think you can definitely handle it. Let me know if you have any questions or comments. Email me, comment on the video on YouTube, and I look forward to hearing from you soon. Have a good day.